Hello, algebra students, and welcome to your lesson on factoring quadratics with coefficients. Before we get into the lesson, we've got these two review questions. I encourage you to go ahead and pause the video now to try them. They'll be a good review of what factoring is and just get you in a good headspace for the lesson today. So go ahead, pause the video, try these two problems now. All right, for this first problem here, when you look at the expression, this is not a quadratic. It is not in the form ax squared plus bx plus c. It's just a polynomial. So in order to factor it, we are going to use GCF, or greatest common factor. The greatest common factor of 3, 12, and -9 is going to be the number 3. And then for variables, they all only have one x in common. So our GCF would be 3x. And then inside your parentheses, these are the three terms you would need to multiply 3x by to get this original problem here. And remember, you could always check it by multiplying it back out and making sure that it equals this. For the second problem here, it is a quadratic. We've got ax squared plus bx plus c. So in order to factor it, it would be factored into two sets of parentheses. Because we've got that x squared, we could go ahead and put x and x. And then for the numbers, we are looking for a pair of numbers that multiply to -18 and combine to -3. In this case, it would be -6 and +3. And again, you could multiply all this out and make sure that it gives you this original problem here. Before we move on, I want to point out what our quadratics look like. All of the quadratics we were factoring last week started off with x squared or y squared or whatever squared. There was no number in front. There was no coefficient. Remember, coefficient is what you call the number in front of a variable. So for example, up here, 3 is the coefficient, 12 is the coefficient. All of our quadratics didn't have a coefficient for x squared. And that was nice because if it's just x squared, we can go in knowing, well, it's going to have to be x and x. I'm only searching for one pair of numbers. The problems today are going to be factoring quadratics with coefficients, meaning there's going to be a coefficient for our x squared. So it says when the expression is written in a quadratic form and a does not equal 1, so for example, here there is a coefficient. It's not just 1x squared, it's 10x squared. We have to do something different. Now, the reason for that is we've got more we're trying to figure out. I can see that this is a quadratic expression, which same as before means I'm going to be factoring into two sets of parentheses. And to get x squared, I know these first ones in the parentheses are going to need an x and an x. But the problem is x times x doesn't give me 10x squared. So there would be numbers here. It could be 1 and 10. It could be 2 and 5. We're not sure. So I can't go ahead and write anything down yet. Same for these last two numbers. I know these two numbers here have to multiply to give me -9, but it could be -1 and 9. It could be 1 and -9. It could be -3 and 3. Again, we don't know. So we could spend some time just playing around with all of these different combinations. Maybe 10, 1, 1, and 9. That doesn't work. Maybe 2, 5, 3, and 3. That doesn't work. Like, you can spend a lot of time doing guess and check. But the part about these that's so much more challenging is the fact that we're looking for two pairs of numbers, unlike the problems we were doing last week where we were just looking for one pair. So because there is a coefficient here, we are going to factor this expression a little differently. Instead, look at all these steps. This is how we're going to factor this quadratic. It looks like a lot, and it is kind of a lot. But I promise the more practice you get with these, it's not going to feel like, oh my God, I have to do 7 steps to get to the answer. So to begin, because there is a coefficient here for x squared, I'm going to start off by multiplying a and c. Remember, if this is ax squared plus bx plus c, that means we're going to start off by multiplying the 10 with the -9. And when we do that, that gives us -90. What we're going to do is use that number we get after multiplying to write all the factors of. So similar to what we were doing last week, where you would look at that last number and think of all the different combinations that multiplies to that. we're going to use 90 and think of all the different combinations that multiply to give you 90. So for example, 1 times 90 gives you 90. 2 times 45 gives you 90. And we could keep going and generate a list of all of the different combinations. Also similar to last week, we are looking for the combination of numbers that can combine to give you B. So that could combine and to give you that 89. Just like last week, thinking, well, could we use like addition or subtraction with one of these pairs and have the answer equal 89? Do you see which pair it's going to be? It's going to be 1 and 90. If you were to subtract 1 and 90, that would give you 89. Remember, we're also looking for a negative 90. If you made the 90 positive and the 1 negative, that would negative 1 and a positive 90 would give you a positive 89, and a negative 1 times a positive 90 would give you the negative 90. So getting rid of all of that. Remember, we've got a positive 90 and a negative 1 that we're going to use. This is where it's different. Those numbers aren't going to be in our final answer. Instead, we are going to rewrite B. We're going to rewrite that middle term using that pair we just found. So we're going to use that positive 90 and negative 1 to rewrite this. So when I do that, it's going to look like this. This is where that positive 90 and that negative 1 went. These are equal to each other. I haven't changed what it says at all. I've just changed the way this middle term looks. It's kind of like the opposite of combining like terms. Instead, I'm taking one term and making it two terms. Once we've done that, now we're going to start actually factoring. Before we can get to the two sets of parentheses, which we know is what we want that final answer to look like, we are going to use GCF, or greatest common factor. The next thing we're going to do now that we've got 4 terms here is we're going to find the GCF of these first 2 terms and then find the GCF of the second 2 terms. So just focusing in on that 10x squared and 90x, what is the greatest common factor of these 2 terms? Well, starting with the numbers, the greatest common factor of 10 and 90 is going to be 10. And then the greatest common factor of x squared and x is going to be x. So just like what we did with that first lesson on greatest common factor, my GCF is 10x. That would go outside the parentheses. And then I would have to figure out what you need to multiply the 10x by inside parentheses to get these terms. For this first part here, we said the GCF is 10x. 10x times x gives us that 10x squared. And then 10x times 9 gives us the 90x. I went ahead and just copied down those last 2 terms. So we're still here on step 5. I found the greatest common factor of these first 2 terms and put it there. Now we're going to do the same thing with the second 2 terms. The second 2 terms, we've got negative. If you need to think of that 1 there, you can. You've got negative 1x and negative 9. What is the GCF of those 2? Well, if you're thinking there isn't one, you're kind of correct. The greatest common factor of 1 and 9 is 1. They both don't have x's, so my greatest common factor is just going to be a number. Remember, when that first term is negative, it means your GCF is negative. So we are going to say our GCF is negative 1. When you use negative 1 for your GCF, again, when you factor into your parentheses, negative 1 times x gives us negative 1x or negative x. And then negative 1 times 9 gives us that negative 9. So at this line here, let's kind of summarize what we've done so far. We multiplied the 10 and the 9, got 90, and found a factor of 90 that we could use to combine and give us the 89. So we rewrote it using those numbers. Found the greatest common factor of my first 2 terms, found the greatest common factor of my second 2 terms, and this is where I'm at. Is there anything you notice about what we've just written here in this line? Well, there's usually a student in class who points out, well, it's the same both times. And I'll ask, what's the same? And they'll notice in parentheses, we've got the same thing both times. We've got x plus 9 and x plus 9. Now, that is what you want. That is key. The reason we are following these steps is to get to that. Right now, we've got this one big term here and this one big term here. when they have the same thing in parentheses like that, that means we can use greatest common factor again. What we're noticing is that this term here and this term here, they both have x plus 9 in common. So picture taking that x plus 9, just like you did here, and pulling it out to be your greatest common factor. If I take out x plus 9 from both of them, what do we have left? Well, in our second parentheses, we've got that 10x left, and we've got that minus 1 left. So, ready? This is what it's going to look like. We are saying this term here and this term here both have x plus 9, so I pulled that out as my greatest common factor. And then we always have parentheses around what's left over. Well, for this first term here, it was that 10x, and then for the second term, it was that minus 1. And by doing that, by using greatest common factor again, we are left with what we wanted. We've got our two parentheses, and we have now fully factored our quadratic expression. Ta-da! The last step here says check your answer, especially for these ones with coefficients where there's more steps than we're used to seeing. You definitely want to check. And we check the same way we've checked all of these factoring problems by multiplying this out and making sure it gives us this. So when we multiply, x times 10x gives us 10x squared. X times the negative 1 gives us negative x. 9 times 10x gives us 90x. And then 9 times negative 1 gives us negative 9. So we've got this right here. I notice I can combine those two middle terms, so that would give me 89x. And then, ta-da, it is the same thing we started with. Right here where we're multiplying it out, I want to point out it's like what we did here to factor, but in reverse. That's how they figured out the strategy to factoring quadratics, is thinking about what happens when you multiply an expression out. Well, when we were multiplying this out, we were taking your 10x times all of this, so 10x times all of this, and your negative 1 times all of this, like there. And then this line here, notice, is the same line we had here, just these are switched around. And then this line here is the same line we had here. So it's like working through these steps in reverse, or I guess doing the multiplication, but in reverse. If you wondered where this came from. What I want to make sure you understand, though, is when we're factoring, same as all these other problems, I'm not changing the quadratic, I'm just changing the way it looks. So this should be equal to our answer. They should be equivalent. I'm just changing it to look like a multiplication problem. So when we check, I should always be able to multiply this out and get my original expression. Because there's a lot going on with these, I've got a couple of examples. We've got this next one here. I've left the steps here just to help you follow along one more time. If I wanted to factor this quadratic expression, notice that there is a coefficient. What is the first thing I want to do to start? If you were saying multiply 10 and 6, you would be correct. When we do that, it gives us 60. We've got, oh, well, you should tell me. What's the next thing we want to do? Write all the factors of 60 out. So we've got all of these different factors of 60. Look at them all. Notice again that I like to go in order. I think it just really helps you make sure that you've got all of the different factors. But here they are for you. Here are all your different factors. Which pair do we want to pick? Now, I think this one here can be challenging, and I'm going to show you why. Some of you at home are probably saying pick 3 and 20. I could subtract 3 and 20 to get 17, and 3 times 20 gives you 60 like we want. And some of you are also probably saying, well, 5 and 12. 5 plus 12 gives us 17, and it also multiplies to give us 60. It can be challenging when you see one pair that, sorry, I'm underlining the wrong one. You see one pair that subtracts to give you that goal number and one pair that adds to give you that goal number. Which pair do we need to use? Well, it's going to come back to this idea of we want it to multiply to a positive number and combine to negative 17. If I was using 3 and 20, what signs would I need on those to make negative 17? Well, I would need a positive 3 and a negative 20. The problem with that is positive 3 and negative 20 don't multiply to give you positive 60. However, for our 5 and 12, what signs would we need on those to make negative 17? Well, they both would need to be negative. We would need a negative 5 and a negative 12. And guess what? Negative 5 times negative 12 still gives us that positive 60. So you can use these signs to help you figure out which combination you need. The pair we want to go with, though, is that 5 and 12, just for what I said. If I make them both negative, that would get me to negative 17, and a negative times a negative would give us that positive 60 we're looking for. Now that we know we want 5 and 12, what are we going to do with them? Well, we want to rewrite this middle term using that 5 and 12. Now, I already mentioned earlier they're both going to be negative. So we can write 10x squared minus 5x minus 12x plus 6. I've rewritten my quadratic using 4 terms. What is going to come next? We're here. So we want to use greatest common factor to factor the first 2 terms, and then greatest common factor to factor those second 2 terms. For my first 2 terms, what is that greatest common factor going to be? Well, the greatest common factor of 10 and 5 is 5. They both have x's, so it's going to be 5x, and I would need to multiply that by 2x and by minus 1 to get this right here. Now, same thing for my second 2 terms. What's my greatest common factor going to be there? It is going to be minus 6. Hopefully you're saying minus 2. Remember, if that first term is negative, our GCF needs to be negative. So we would have minus 6, and then again, the 2x minus 1 to get this. We are almost done. What's our next step going to be? The next step is using GCF again. Now, before we do that, I want to mention some students will say, I think we want to multiply out the 5x and multiply the minus 6. If we multiply this back out, what's going to happen? It's just going to take us back up here. Remember, our goal is to factor it. We're trying to get to those 2 parentheses there. That's what it's going to look like when we've finished factoring it. If you were to multiply this back out, it's just going to take you back up here. So to finish factoring, I noticed that both of these have 2x minus 1, something they have in common. So that 2x minus 1 becomes my GCF, and it leaves me with 5x minus 6, my other set of parentheses. But wait, are you telling me we should check our answer? Let's do that. You check, you want to multiply all this out. It would give you the 10x squared minus 12x minus 5x plus 6. And then when we combine these, it gives us what we started with. I've got ones for you to try now. This first one here looks like this. We've got 10r squared plus 3r minus 4. Go ahead and try factoring that now. How'd you do? Well, you want to start off by multiplying your 10 and your negative 4. That gives you negative 40. You are looking for a pair of numbers that can multiply to negative 40 and combine to 3. In this case, that pair would be 8 and 5, because 8 times 5 gives us 40, and 8 minus 5 gives us 3. I guess it should say 8 times negative 5 gives you negative 40, and then 8 and a negative 5 will give you that 3. If you're using a positive 8 and a negative 5 to rewrite this, it is going to look like this here. We've got our 4 terms now. So now we could use greatest common factor to factor the first 2 terms, which would look like this. And then when you use it to factor the second 2 terms, it'll look like this. Notice for both of these, we've got 5r minus 5r plus 4. That becomes our greatest common factor. So we take that out in front. And you are left with 2r minus 1 for your second parentheses. Now there's something I did here that you might have done differently. We figured out that that pair of numbers we want to use is a positive 5 and a positive 8 and a negative 5. And so I wrote 10r squared plus 8r minus 5r minus 4. But what if you wrote it like this instead? What if instead of thinking positive 8, negative 5, you thought negative 5, positive 8, and you wrote out this? Do you think that's okay? Are we going to get the same thing? Some of you might already know that answer if this is how you initially did it. But I don't know. If you don't know something, let's try. Let's keep going with it. So we're trying to see if I wrote this in a different order, if I'm going to get that same end result. Well, when I go to use GCF, it's going to look different because instead of a 10 and an 8, now I've got a 10 and a 5. So now my GCF is 5R, and it's going to change what's in the parentheses too. Same thing over here. Before I had a 5 and a 4, so my GCF was 1, but now I've got an 8 and a 4, so my GCF is 4. So it's looking really different over here compared to what we had before. But remember, it's not what it looks like in the middle steps. It's that final answer. Here, we've got 2R minus 1 in common, so that becomes our greatest common factor. And then the 5R plus 4 is left over. Now, comparing these two results, are they the same? Are they different? What do you think? They're written in a different order. So if you're looking at them here, we've got the 5R plus 4 first. Here it's last. We've got the 2R minus 1 second. Here it's first. Remember, this is multiplication. This means 5R plus 4 times 2R minus 1. 2R minus 1 times 5R plus 4. Is the order you write stuff with multiplication important? If you change stuff around with multiplication, does it change the meaning? No. If that's confusing looking at this, just think about numbers for a second. Is 8 times 5 the same thing as 5 times 8? Yeah. Multiplication order doesn't matter. So the same thing is true with these. It does not matter the order you put those binomials or the order you put those parentheses in. They mean the same thing. So what that means is, as I was going through this work and I showed this, and if you had this on your paper, doesn't mean you're doing anything wrong. You just put them in a different order. Now, it doesn't mean this work in the middle is going to look different, but that final answer should be the same. I think that's important to mention. There is one last one like this for you to try. You're going to factor 8x squared plus 21x minus 9. All right. So when you are factoring this one here, you start off by multiplying the 8 and the negative 9, which gives you negative 72. You are looking for a pair of numbers that multiplies to 72 that combines to 21. You write out all the factors of 72. You are going to find that pair is 24 and 3 because 24 minus 3 gives you 21, and 24 times the negative 3 gives you negative 72. When you go to rewrite your quadratic using those numbers, it could look something like this. Or we learned with that last problem, you could also write negative 3x plus 24x. You should get the same final answer. When we go to factor with GCF, the first two terms, the GCF is 8x. And then we would have x plus 3 in parentheses. Second two terms, the GCF is negative 3. Don't forget that negative. And then we would have x plus 3 in parentheses. They both have x plus 3. That becomes our greatest common factor. And then we've got 8x minus 3 in the second parentheses. And of course, you would want to check it, and you see that it equals this. Now, my bonus question for this one is when you go to do this rewriting step here, we had to do all of this to figure out what that pair of numbers was, right? We had to multiply 8 times 9 to get the 72, and then find the pair of numbers that multiplies to 72 that can combine to 21. What if you didn't do all this? What if you just picked any two numbers? So I randomly picked 3 and 18 that combine to 21. Now notice 3 times 18 doesn't give us 72. It gives us 20, 40, 60, minus 54. So it's not giving us the number we said earlier. What do you think would happen if I tried to use the 3x plus 18x to factor this? Well, we could keep going through all these same steps, right? So just like before, I could start off by finding the GCF of my first two terms, finding the GCF of my second two terms, which when I do that, it'll look like this. But the problem is, unlike before, when I do random numbers like that, they're not going to have anything in common. There's nothing I can do after this step. Unlike over here, where we had both terms with an x plus 3, and we could finish factoring by saying they both have that in common. The reason we are doing all of this is not only to split it up into two terms, but also to find those two terms that when you split it up, they give you that common factor to help you finish factoring. So that's the reason we have to do all this. That is the reason why you're looking for a pair of numbers that both multiply to 72 and also combine to give you that 21. if you were wondering. There is one last part to this, just some other ways you could see questions, or other ways questions could be asked that are really getting down to the skill. One example is which binomial below is a factor of 9w squared minus 15w plus 4. When it's saying which below is a factor, they're saying is when you factor this out, you get two sets of parentheses. Which one of these is a factor? Which one of these is one of those two sets of parentheses? So to figure this out, you can try doing some guess and check, but I think the best strategy is just to do what we've been doing, factor it out, see what the two parentheses are, and then identify which one of these is indeed a factor. Go ahead, try that now. All right, when you do that, you should be getting C for one of your two factors. It would be 3w minus 4 and 3w minus 1. One other question. Oh no. Okay, one more question. We've got the area of a rectangle is represented by 8y squared minus 41y plus 5. And the question is, what is the length and width of the rectangle? We had seen something similar to this before last week, I believe. It goes back to what you know about area. So when you're thinking of area of rectangle, what comes to mind? Obviously, like what area is, hopefully comes to mind. Like area is the space inside, but the most helpful thing here is going to be how you calculate area. And we calculate area by using length times width. Now, a lot of what we did back in Algebra 1A with area and polynomials is I would tell you the length, I'd tell you the width, and you would have to multiply them together to figure out the area. Here it's worded differently though. Here I'm giving you the area. The area is all of this. So I'm giving you this area. It is asking for the length and the width of the rectangle. So I'm telling you what the area is, but we are trying to figure out the length times width. Well, notice we are trying to figure out what times what gives us this polynomial here. In order to figure that out, we just have to factor. If I factor this and figure out what two things multiply together to give me this, I figured out what the length and the width are. So when we factor 8y squared minus 41y plus 5, you're going to use 40 and 1 to rewrite the 41y. And then when you factor with greatest common factor of the first two is 8y. 8y times y gives me 8y squared. 8y times that negative 5 gives me the negative 40y. The greatest common factor of these two is negative 1. Negative 1 times y gives me negative y. Negative 1 times negative 5 gives me positive 5. And then last but not least, they both have y minus 5. That is their common factor. And 8y minus 1 is left over. So by doing that, by rewriting this as a multiplication problem, I can see that this equals y minus 5 times 8y minus 1, and therefore the area equals length times width. So I know these are the two sides. That one side is y minus 5, and the other side is 8y minus 1. That is everything in this video today. Hopefully you found this video helpful. Please reach out to us if you have any questions. Thanks for watching.